Do the shortcuts work for everything?
Oh,
It's a shortcut that you should always check if a certain scenario arises. For example, in this problem here, you'll notice that you have how many terms in the sequence? 4 of them. Always check real quick if the 4 terms can be grouped. Because if they can be grouped, you can pull GCS. That's a very efficient, quick way to check for your terms, okay? You could go through and list out all the terms of 81 and all divided by 3. You will get there. But if you recognize one of the things that you can check is that you can see if you have a GCF here and here. Another trick is whenever you have 3 terms, if your powers start at like 8, 4, and then you have a constant, always check to see if you can factor it like you can any other normal trinomial. Those are the 2 little shortcuts that you guys tend to forget about as you're doing these larger degree polynomials. Okay? So anytime you have 4 parts, always stop and check if you can group them. Because no matter what your degrees are, it's a great shortcut to double check. Okay? So when I go through this one and I check it via grouping, what's my GCF of 3x to the 5th and x to the 4th? Pull that out. And now I have 3x plus 1. Take out the negative 81, and I have a 3x plus 1. X to the 4th minus 81 is a difference of squares. You get x squared minus 9, x squared plus 9. I believe this problem asked us to find all possible zeros, correct, LeBlanc?
Can you just do the whole root? That's what I did. I just added 81 and then
Yeah.
the root 4.
But what happens, do you remember you have an imaginary though?
Because it has just all zeros.
But here's the problem, when you have a 4th root, that means it's an x squared inside of it. You eliminated the imaginary possibility. Break it down as far as you can before you do that, because you can accidentally eliminate a possible 0. Because this is a 5th degree polynomial, you should have had 5 zeros. When you did it, you probably only had 3. You had 2. Oh, then you forgot to do the 3x plus 1.
No, I did that.
Then you forgot to do plus minus.
But then wouldn't that just be 3?
Watch what happens. At this point, it did say just find all zeros, correct? So I could have done this and done plus or minus 3, plus or minus 3i, and negative 1/3. 1, 2, 3, 4, 5 zeros. If you did what you did, you get your x to the 4th equals 81, and you're right, the 4th root of 81 is 3, but it should have been plus or minus 3. But inside this 4th root was an x squared, so you had 2 of those x squared, so you had to do a 9 and that. That's the trick when you have 4th degree polynomials. Make sure you break it apart into the squares before you start taking roots, okay? Because by doing that, you just eliminated some possibilities. Okay? What else we got? That's on the 6, 7, right? Now, what times what is negative 36? You have to go to get negative 5. Here's your shortcut. It's 3 terms. Your first term has a degree of 4. The second one has a degree of 2, which is half of 4. So try to factor it like you would any other boring trinomial. So you get x minus 9, or x squared minus 9, and x squared plus 4, which gives you zeros at plus or minus 3 and plus or minus 2i. You don't necessarily have to use synthetic division throughout all these problems when there is other alternatives to help make it go quicker. Okay? Yeah. Did you do synthetic? You would have gotten it. Gotcha. Well, we actually did this problem at the beginning of the chapter too.
Technically, it was a long time ago.
No, I said we did this beginning of the chapter, comma, 2, T-O-O,
Oh.
as in also. Yo repito. Lo siento. ¿Cómo estás? Qué bueno. Hola. Pregunta para de tarea. ¿Qué número es? Oh, parlez-vous français?
If it's asking for all possible, if it's asking for all possible answers, so should you not use synthetic?
No, you can.
But then you don't get I.
Yeah, you do.
I got.
Yeah. What happens when you use synthetic division, you'll be able to find the real solutions with synthetic, so you would have noticed you had a plus or minus 3 right away, and then you would have been left over, if you, in your terms, you would have had a 1, a 0, and a 4. So it would have been x squared plus 4, and that's how you would have been able to get that. What times what is negative 36? You add together to get 5. Anytime you see 3 terms, if the degrees go degree, half of it, nothing, factor like a trinomial. Or at least try to. Okay? Any others on these? All right, let's go backwards. Pass them up, please. We'll go backwards. And this is kind of re-emphasizes the whole idea of why I kept asking you the differences between terms and zeros. Excuse me.
I saw today because we have this week and I have it.
Oh, thank you. Yeah, I'm trying to get everything caught up with everything. Yeah, but everything that we've done up to now was that I was trying to get you guys accustomed to the lingo of the differences between zeros and terms. And I think for the most part you guys are getting the hang of that. So if I say 2, 0, and negative 3 are the zeros of some polynomial, what are the terms? If 2, 0, and negative 3 are zeros of some polynomial, that means that's where it's crossing the x-axis. What are the terms then that create it? So we have, what was it, Popcorn?
X plus 3. X minus 2 is X.
And just x, very good. That's it. We've been saying that all along. Remember when you guys found a 0 using synthetic? If when we did synthetic division, and all of a sudden that negative 2 wound up being a 0 down here, I said, hey, knucklehead, right off to the side, x plus 2 as its term. So that way you keep it going. Yes, ma'am?
So if you do synthetic division, then would you like another one to get down to the 3 coefficients? Like, okay, if you do that,
Yeah.
and then if you have to do like another one underneath it, so when you write your equations, you write like x plus 2, and then the other number that you want.
Yep. That's kind of, we just keep the tally going. That way you know what it was there, okay? So what happens here is that knowing what your terms are then allows you to write out what the polynomial is by foiling. Foil this out and multiply everything by x. You get x squared plus 3x minus 2x is plus x minus 6. Then you multiply everything again by x. So the polynomial that it gives us, zeros at 2, 0, and negative 3, would wind up being x cubed plus x squared minus 6x. That's what it is.
So are we just reversing what we did yesterday?
Yep.
Gives you all the parts.
Okay.
Gives you all the parts.
What's that?
This gives you all the parts. This is crazy.
Yeah.
Are they gonna not give us the part?
What do you mean?
Like, is there gonna be like the next thing you're gonna teach us is like when they give us no part and then we like figure out the parts? Like,
So if I say blank are the zeros,
and this is
what's the polynomial?
Yes.
Yeah, let's do that.
Let's do that.
I think we
All
should.
right. So if I don't give you a 0, what's the polynomial?
Polynomial.
Not 12.
12. Okay. Yay! Yeah, I have to give you. I have to give you something.
I was just gonna make something up.
But what happens if I do this?
I knew there's something.
What if I give you imaginary zeros?
Oh heck no.
Just think about it.
That's like the square root of 1.
Thank you.
Ugh.
Now, if I want to write out the polynomial that has 2 and then plus and minus negative I as zeros, we all know how to figure out what the term is for the integer value of 2. It has to be x minus 2. That's easy. When it gets to the imaginary, though, you have to start to think about, well, how do you get an imaginary number? In order to square root of what? A negative. Okay, we have to be able to take a square root of negative. So if you follow along the same pattern here, we took 2, it was x minus 2, which means this would have been x plus I and x minus I. You okay with that? Now, disregard this x minus 2 for right now. And let's just work solely with this x plus I, x minus I. Notice what happens, and you're right. Isn't that just a difference of squares? It's first term squared, subtract last term squared. What is I squared? Try again. Negative 1. So this is x squared minus a negative 1, which is? So your terms would have been x minus 2 and x squared plus 1. In order to get an imaginary number, you wound up having to take a square root of a negative. So if you think about it, x squared plus 1 equals 0. Well, x squared is negative 1, therefore x is plus or minus I. Well, that's where that came from. Okay, that's where that came from. And then it's just a matter of pulling that out. Excuse me. X cubed minus 2x squared plus x minus 2. There's your polynomial of nth degree with those 3 zeros. Third degree polynomial, I had 3 zeros, and I worked through it. Not terrible, is it? So you're worried about that worst case scenario, but yet it all follows the exact same pattern. It's that x minus whatever your 0 is, whether it's an imaginary or a real value. Okay? What about this? If I want to write a polynomial of nth degree, all that means, that saying just stands for whatever the degree winds up being with that many zeros. So if I want to write a polynomial of nth degree here, do I have enough information? No, I don't. Because i's come in what? Pairs. What's it missing?
Negative.
It's missing the negative. It's missing the negative 4i. I's only are created in pairs. I thought it was a 4, so it's a negative 2i. So sometimes what they will give you is just one of the I values. Therefore, you have to write down the second one. Okay? That's how that'll work. It goes the same way if they do this. If they say 3 minus 2i as one term. Oh, you need an eye chart? Hold on. I'll rewrite it for you.
He's gonna write letters.
Yeah, he's gonna write the letters.
Yep.
Unpredictable. It starts with this. I know it starts with this. Okay, and then it goes like
You can do that.
That's crazy.
Why not?
Whoa.
I don't know.
That's it.
Don't they usually put more letters than they
I don't know.
Yeah, it's like, yeah, you're
Shut up. Nobody cares. I was just trying to be funny, and you guys go, typical Murphy. Yeah, where's Jory? She would have laughed.
She got a no. She's not even here.
So if there's a 3 minus 2i, what else should there be?
2i.
There should also be a 3 plus 2i. Remember, they're always going to go in tandem with one another. And I'll talk about how you work with these here in a second. Okay? So going back to this first one, if I have 4, 2i, and negative 2i, hopefully whenever you have just a constant next to I, you'll be able to tell what the term's going to be rather quickly. This one is easy. It's x plus 4. The other one's going to be, well, what square root is going to give me plus or minus 2i as a solution? What would it be? What are you saying? Well, if I take the square root of what is 2? 4. The square root of what, is it a positive 4 or a negative 4, gives me i's. So if I take the square root of a negative 4 over to here, so if I square this and square this, that means x squared equals negative 4, which means x squared plus 4. So this is x plus. It's a difference of squares, guys. You can write it out long form if you want. You can do this also. X minus 2i, x plus 2i, and FOIL it out if you want. This is just the shortcut. X squared minus 2i plus 2i minus 4i squared. That drops, you get x squared plus 4. Same thing. The pattern is just square them and add them together. What's that? We get x squared minus 4i squared. What's I squared? Negative 1. So negative 4 times negative 1 is plus. That's where this comes from. It comes from back in chapter when we dealt with the I values.
Oh, actually,
Okay. Let's look at this one. What did I say? So I have zeros at 5 and 2 plus 3i, which means there has to be another zero not listed. What would it be?
2 minus 3i.
2 minus 3i. So I'm assuming that everybody understands that this is going to be x minus 5. We okay with that?
Yeah.
I'm going to worry about that at the end because I'm going to show you how to work with these. How do you write out the terms? I'm going to show you guys a long form way that you might be able to pick up on a shortcut rather quickly. Okay? Now, if we do this long form, our zeros are going to be x minus 2 plus 3i. And then the other one would be x minus 2 minus 3i. Everybody okay with that?
No.
What do you mean no? Isn't this x minus 5? What did I change? Nothing. I changed nothing. I took x, subtracted the 0. The 0 is 2 plus 3i. That's it. Now, there's a property, a little known property in math that allows you to do this. Remember what that is? No. When you regroup stuff, you're associating in different groups. The associative property tells you basically you can move your parentheses around and it doesn't change the solution. You can do the exact same thing here. Watch what happens. I'm just going to bring this x minus 5 along for the ride. I'm going to get x minus 2. And distribute my negative, I get minus 3i. Do the same thing. I get an x minus 2. Distribute the negative, and I get a plus 3i. From here, you're going to use something that's new. And this is a great algebraic trick that we use I don't know, there might be 3 or 4 occasions throughout the entire school year in Algebra 2 that we use it. But I know in pre-calc you're going to use it a ton. Also in calculus you use it a ton. It's called U substitution. Basically, U substitution means you let something that looks like crap look like something that's easy. For example, this right here is rather messy. But if I use U substitution, it's going to look a lot nicer. All I'm doing is I'm letting this value, this variable u, equal x minus 2 for right now. I'm making something that looks like crap look a lot easier. Now it's just a difference of squares, isn't it? U minus 3i, u plus 3i. It's a difference of squares. So when you do this, you wind up, let me move this up a bit here. If you FOIL this out, u squared, the middle terms will drop, and then we get minus 9i squared. What's 9i squared? Sorry, minus 9i squared. That would be plus 9. So you get u squared plus 9. Well, what is u squared? It is x minus 2. FOIL it out. X squared minus 4x plus 4 plus 9. X squared minus 4x plus 13. And way back up here we had lonely x plus 5. Oops, let's rewrite it. And now you can FOIL it out to get your polynomial nth degree. The trick there is what was it minus? Oh, I had it was too close to the sign there. I thought it was a plus. So what happens here, guys, is that I could have FOILed it out from here because you have that first term. There's still a difference of squares. But by putting in that singular value of u, I just made it look a lot easier. And it turned into a very fast difference of squares. Okay? Now, the trick is that you still have to know how to FOIL, and please don't kill puppies. X minus 2 quantity squared is not x squared plus 4. Mr. Gonzalez would roll over his grave. See what I'm saying? It's worse than killing puppies. So then all you would, too soon, right?
Way too
So now you would FOIL it out. Was it 65? So, and then you're done. So the trick is whenever you have zeros of what's that called? Conjunctive? I think it's a conjunctive imaginary number. You just reuse it as like a little u substitution. Yes, ma'am.
Why did you go from u squared minus 9i squared to x minus 8 squared?
Because when I went from here, remember, what did u stand for? U was x minus 2. So wherever I have a u, I just resubstitute in that. And then I FOILed it out and added the 9. What I was doing there, I was taking that nasty looking difference of squares with 2 extra parts to it, which I could have FOILed out, which is awful, to make it easier on myself by using that quick little substitution. Basically, here's the trick. Square it, add them together.
What's the trick? Wait, can you say that again?
That again. I'll show you. Give me a number.
7.
So 7's a 0, and let's say 2 minus 5i. So I got one more example to show you that's really, really quick. So if I have 7 and 2 minus 5i as zeros, What am I missing? Good.
You work at Target?
So now, the 7 one is easy. That's an x minus 7. The secondary one, remember, is x minus the quantity 2 minus 5i.
Does it always have to be x minus?
It could have been x plus, and then, yeah, if it was x plus, then what's the other one it's missing? It does,
X match.
yeah.
Whatever.
Yep, you,
Why is there?
well, if your 0 is 7, what's your term? X minus. If negative 4 was your term, it would have been x minus and negative 4. We just wrote it as x plus. It's the same rules apply for imaginaries. They just look uglier. Okay? So, just keep going. Now think of it in terms of foiling everything out. Between here and those two, it's a difference of squares. It's a plus b, a minus b. A squared minus b squared is how that would work out. The middle term goes away. So it is quite literally x minus 2 quantity squared minus, oops, 5i squared. What's 5i? Well, what's 5 squared? So negative 25 times negative 1 is 25. So it's going to be x squared minus 4x plus 4 plus 25. It's always going to be this term squared plus that coefficient squared. Always. It's a nice trick. Or FOIL it out, and you'll get the same thing. Okay? And then just put in.
Wait, the coefficient is squared?
Yeah.
I'm confused on how you're getting 25.
What's 5 times 5?
25.
Stop.
So like the I doesn't fit.
What's remember, what I did here was if you FOIL all that out, you're going to get negative 25 I squared, which is negative 25 times negative 1, which is,
Okay.
that's where it's coming from. Mhm. And then just FOIL from there, okay?
It's not happening.
Yeah, I just didn't write it all the way out yet. You're right. And that's why I was about to take a sip of water and say, then you could figure the rest of it through. Okay? Try another one. Can I go to another one here?
Give me a second.
One.
That's not on.
All right, one more, and then I got to show you something different. What if you're given those two zeros? Correct. In this case here, you see how they give you two positive 4i's? Which means, what are they missing? Two negative 4i's.
Is that a double zero?
It's a double imaginary zero. Just think about it.
So like for the graph, it would be like change the direction of the imaginary.
Yeah. Would this ever cross the x-axis? No. So think about it. What gives you plus or minus 4i? X squared plus 16, and then x squared plus 16. And then you would FOIL that out. Okay, that's how that would work. So you get x to the fourth, 32x, and a 256. Tails up, four, in this case, we know it's 4 imaginary zeros. Yes, ma'am.
Wouldn't it be 32 squared?
Oh, thank you. I'm so used to doing regular trinomials. Yes. Yeah, tails up. It doesn't cross the x-axis. There could be 3 changes in direction. There probably are. But okay. Let me show you the other new thing from today. It's actually really, really easy. You've done it before. You just didn't know you've done it. If I want to write out a cubic function given zeros at a secondary point. You did this when I asked you guys to write out a quadratic given zeros at a secondary point. You used intercept form. Well, there's an intercept form for cubics as well. Cubics have how many zeros? They have 3 of them. X minus p, x minus q, and x minus r, where p, q, and r are the zeros. And they will be given to you in some sort of ordered pair fashion. In this case, you have 3 ordered pairs. We have ordered pairs at -3 and 0, 2, 0, 5, 0, and then an other point at 0 and -15. Of those 4 points, which 3 are your x-intercepts? So you have zeros at -2, or excuse me, -3, 2, and 5, which means that your terms,
Would they give us these answers?
yeah, they have to.
Well, I mean, like, isn't there a way to figure it out? Do you give us, like, reference?
This case, you're going to have to be given zeros. Just like with intercept form, you're given zeros. This thing works the same way. You have to have zeros. So you have x plus 3, x minus 2, x minus 5, some value a, and a y. Gee, what do you think x and y are going to be represented by? That other point. That other point is your x and y value. What do you think you're solving for then? A. Just like we did before. Because your x and y value are given to you, just like we did with quadratics. Now, ladies and gentlemen, at this point, a lot of you can probably multiply those things together without a hassle. But not all the time are they going to give you ordered pairs with a 0 for x. So guess what? There's a button on your calculator that looks a lot like a parentheses. I didn't know if you knew that. It's crazy. But if you type in parentheses 0 plus 3, 0 minus 2, 0 minus 5, all within a bunch of parentheses, especially when you have x values that aren't 0, because I have a lot of faith in you, but sometimes I don't have that much faith in you to make a silly mistake. Press the buttons in the calculator. It's not going to hurt you. Ouch! I'm joking. So, -15 is going to equal 30 times a. So, now what do you do to solve for a? I don't know, cry. Algebra, yay! There's your a value, which means then your answer, your final answer is just going to be y equals -1/2, blah, 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 blah. Just like we did before, you don't need to multiply these out. You're basically solving that simple formula for a. That's it. It mirrors the exact same thing that we did when we worked with quadratics. Yes, ma'am?
What is A?
A is like a scalar. A tells you how high up the peaks and valleys are going to be depending upon that value. That's all it is. I'm not worrying about, due to kind of like the lack of time of things that we have, I'm not really worrying about relative maximum, relative minimum, how to figure all that kind of fun stuff out. it's not that, and teaching pre-calc last year, I know that it's not that big of a deal because it's just a button on the calculator. So it's no big deal why we don't have to get it this year. It's a 1. The cursor thingy, the marker might have moved.
So we just have to write it out as like.
Yeah, don't FOIL that out. Please don't. You don't need to. There's no reason to FOIL that out. This is the only time you don't have to FOIL it out, okay? They gave you some problems. Oh, I don't remember what I didn't write it down.
No homework?
Yeah, no homework. Yay! No. That's a joke. You're right.
That's not the worst joke.
That's also true.
Jory would have had like.
Where's your pencil?
No, this is the wrong one. Yeah, George would have field day today.
Yeah.
At least we know she was here in spirit, right? Did you?
Okay.
I hope not. Do these, please.
Charlie plays art.
Do those, please. Please make sure you write down the correct section. We skip over 6.8, just so you know. We'll worry about 6.8. We've actually done most of 6.8 already. It's called graphing of these, plotting via zeros. You've already done it. We've been doing it all along. All right. And I do believe that we don't land on 46 because why should I try to make it look like I know what I'm how to count? It's overrated. Okay. Ote?
What?